Okay, so we are practicing the gas laws, and here is a couple problems that we were working on, and so this way you can check yourself, make sure you're doing it right. We have a gas, so we can use our gas laws. We are given a volume of 2.5 liters. So I'm going to write down what I'm given. I'm going to read this carefully and look at what I'm given. I've got a pressure of 100 kilopascals. All right, watch the Edpuzzles so you can understand these what pressure is and the units for pressure. We have a new volume, so I don't know the new volume, so that's my unknown. And I have a pressure, a new pressure of 108 kilopascals. All right. And so that tells me what I'm using. Notice this is a combined gas law because it has Boyle's law right here. All right, which shows that pressure and volume are inversely related. All right, what that means is if one goes up, the other goes down. Okay, so notice I've got my pressure went up. All right, so if I increase the pressure, that is going to decrease the volume. The volume is going to go down. So let's see what happens. When you're solving these problems, you look at what you're given, you look at what your unknown is, and then you write down the equation that you're going to use. So I'm going to use Boyle's law. Pressure times volume equals pressure times volume. And then I'm going to substitute in. So for pressure, I've got, maybe I can put this underneath that well, no, I'll do it over here. So for pressure, I've got 100. And I'm going to take out the units while I'm just doing the math. And the volume that goes with that 100 was, right, my two initial numbers here was 2.5. All right, and then my new pressure was 108. And then my new volume, I don't know. That's what I'm trying to find out. So that's my unknown. Now I want to get my unknown volume all by itself. These are multiplied together, so I'm going to divide by 108 because that's 1. And 1 times V is V. And then now I've got to do that on the other side. If I divide the right side by 108, I have to divide the left. And now I have just a fraction. I'm going to type that in here and figure out my answer times 2.5 divided by 108. All right, and notice my, in the question I had 2.5, I have two significant digits. So I'll just do two significant digits here and I'll say 2.3 is my new volume. And then you always, in your answer, you need the unit. So volume is in liters. And so this would be my final answer. All right, and that's all you have to do to solve these equations. It just takes practice. So let's change colors. Let's go to green. I've got a gas, so I'm going to use my gas laws. Let's see what I'm given. I've got 1.75 liters, and that is going to be volume. That's my initial volume, 1.75 liters. And I've given a temperature. Kelvins is a temperature. Again, watch the Edpuzzles so you can understand what kelvins are. And that's 305 kelvins. All right, and then that gas is inside a balloon. I dip the balloon into an ice bath and cool it down to 264. So I have a new temperature of 264. And it says, what will be the new volume? So that's my unknown, the new volume. I don't know. All right, so I'm given these things and I'm going to find the volume. So what I've got here is temperature and volume. If you look at your combined gas law, here is Charles' law right here. Volume divided by temperature equals volume divided by, oops, I made a T. I said V, but I'll just quick change it into a V. Divided by temperature. All right, so if they're divided, all right, that's Charles's law. Charles' law. All right, volume divided by temperature equals volume divided by temperature. All right, that means it is divided by, that means it's a direct relationship. All right, and what that means is if the volume goes up, the temperature goes up, and vice versa. They both act the same. If one increases, the other increases. All right, so what's happening here? Well, my temperature is decreasing, right? My temperature went down from 305 to 264 kelvins. So that means the temperature is going to go down too. All right, they're directly related. So I've got my givens, my unknown, and my equation. Now I'm going to substitute in, all right, volume is 1.75 liters. Oops, I guess I'm going to have to erase because I keep making mistakes. Let's get the eraser here. Oh, that's not what I wanted to change. Never mind. All right. Let's say I didn't put liters. I'm just erasing that. 1.75 liters. And the temperature with that was 305. All right. And then my new volume, I don't know. And my new temperature was 264. Okay. So I've got a proportion. I'm going to cross multiply to get my, to make that into an equation. All right, so I'm going to multiply 1.75 times 264, and that's going to equal 305 times my new volume. All right, this is the new volume. Now I've got an equation. I go from a proportion to an equation, and then now I want to get this variable all by itself. It's being multiplied by the 305, so I'm going to divide by 305. That's 1. So that gives me that variable all by itself. Got to do that on both sides. Divide both sides by 305. So I'll put that into my calculator. So I've got maybe I'll just start over. I'll just get rid of that. 1.75 times 264 kelvins divided by, and you could do that, you don't have to do this in Desmos, you could do this on your calculator or even on your phone, divided by 305. All right, however you do it, make sure you get the right answer, because a lot of times people set it up but they can't do the calculator right. So I've got, let's see, I had 3 significant digits here, so I'll go ahead and have 3 significant digits here. So 1.51. The next digit's a 4, so I'll leave that as a 1. And then the unit for volume is liters, and that is my final answer. And then I'll check it. I'll say, okay, the temperature went down. Did the volume go down? Yeah, it went from 1.75 to 1.51. So it did go down, so that's probably right. All right, now we have a new color, and we've got a gas, so we're going to use our gas laws. All right, in a syringe, which you use to like take medicine or pull things out, like you pull it back and that makes the liquid come inside and you push through and then it pushes the liquid out. So that's a syringe. It has a volume of 10.0 milliliters, so my initial volume is 10.0 milliliters. And my initial pressure is 100 kilopascals. All right. And I've got the plunger is depressed, so we push in until the volume is 7.5. So my new volume is 7.5 milliliters. What is the pressure going to be? So what's my new pressure? All right, so volume and pressure. Well, we know Boyle's law says pressure times volume equals pressure times volume. All right, they're inversely related. If my volume is going down, my pressure is going to go up. All right, so now I'm going to substitute in to the equation. So my pressure was 100. The volume that was with that pressure is, right, these pressures, the 10 milliliters went with the 100. All right, so I have 10 milliliters. And the I don't know the new pressure, and the new volume was 7.5 milliliters. All right, so I want to get this new pressure, and it's multiplied by 7.5, so I'm going to divide by 7.5 on both sides. That's 1, so my new pressure is going to be whatever that is. So I'm going to take 100 times 10.0, and then I'm going to divide that by 7.5. And I get 133.3333 repeating. So notice my original pressure was 100, so I'll just make that 133. And the units I was using was kilopascals, so I have kilopascals. And that is my final answer. All right. Gets easier and easier the more you practice. So let's check out number 4. So I've got 3 liters of gas. So my gas laws, I'm thinking gas laws, and I've got a volume. It's 3.0 liters. I've got a pressure, 1.5 atmospheres. Again, Edpuzzle, watch that so you understand what atmospheres are. And then I've got a temperature. All right, and it's 20 degrees Celsius. All right. When we have all 3 of these things going on, we want to convert to our Celsius to kelvins. All right. And that's pretty easy because a Celsius degree is the same as a Kelvin degree. All right. The only difference is that whereas freezing is at 0 degrees Celsius, all right, absolute zero, when the molecules are completely stopped, is at 0 degrees Kelvin, okay? And so 0 degrees Celsius, the molecules are still moving a little bit. That is actually 273 degrees Kelvin. So if I want to know kelvins, I take my Celsius degrees and I add 273. That's the magic number. And so that means my kelvins, in kelvins, that would be 293 kelvins. All right, so my temperature in kelvins is 293. So you kind of know it's kelvins. If you got a really high, big number for your temperature, it's probably, that's kelvins. Now what else have I got? It says the pressure and temperature are increased, both of them. So the pressure goes up to 2.5 atmospheres, so I have a new pressure. And my new temperature is 30. So now I'm going to take, if I take 30 plus 273, that's going to be 303 kelvins. So my temperature also went up. My new temperature was 303 kelvins. All right, what is the second volume? So the second volume is what I'm trying to find. That's my unknown. So I've got all 3 of these things going on. So now I'm going to use the combined. All right, I'm going to use Charles' law and Boyle's law combined. All right, pressure times volume, they're inversely related, and then directly related to temperature. All right, and that's on both sides. All right, so I write down my equation and now I substitute in. So my first pressure was 1.5. My first volume was 3.0. My first temperature was 293. My second pressure was 2.5. The volume, second volume, I do not know. And my second temperature was 303. Okay. So what I can do, and you know, everyone has whatever their ways that they think are easier. I think it might be easiest to take this and figure out what that number is. All right, so let's make that into one number, and I have 1.5 times 3.0 and that's divided by 293. All right, and I get that long number there. So I'm going to look at my data here, what I've got. I really have at most 3 significant digits, right, with the temperatures. All right, so I'll just worry about 3 significant digits. So remember, if you have a decimal, you start at the Pacific and you fly over the zeros and then you count 3. So all I need is the 1, 5, 3. And so that would go, I would round, maybe I'll just, I'll go ahead and, well, I would round up to 4. So this equals 0.0153, and I'll go ahead and make that, the next digit is a 5, so I'll make that into a 4. All right, and then now I'm going to find this number. And that would be 2.5 divided by 303. Okay, and so I've got a decimal, so I'm going to start at the Pacific, fly over the zeros. There's 1, 2, 3, so I'll stop at the 5. So 0.00, those don't count, 8, 2, 5. Those are my 3 significant digits. And then I have the V. Okay? So I'm just simplifying. All right? When you're doing algebra, before you start doing things to both sides, it's usually a good idea to simplify. Okay? All right, so now I'm going to divide this guy. Right? A number divided by itself is 1. So I have to do that on both sides. And so I get my volume. My new volume is going to be whatever that is. So I'm going to divide that out. 0.0154 divided by... The idea is you don't want to round, the less rounding you do, the better. There are other ways to solve this, and if you want to do it that way, that's fine. So 1.8, and then now I only want 3 significant digits, right? So I'm going to say 7. And volume is in, if I forget, I can look over here. I was given liters, so it's liters. Okay, and then we'll do the check. That's an 8. So now this is not so simple because it's a little more complicated. There's 3 things going on. So basically our temperature went up Pressure went up. So it's, yeah, if the temperature goes up, you think the volume should go up, right? But if the pressure goes up, that makes the volume go down. So they're all kind of working together. So it's kind of a little bit harder to check with this. So we'll just have to hope for the best. 1.87 liters. All right. Make sure you do it. I often make a mistake, so you might catch one of my mistakes. You get bonus points if you catch one of my mistakes. Okay, so here we go. Let's get a new color. What haven't we done? I'm going to go with the blue. All right, so we have a gas. So gas laws. In a syringe, right? We remember what a syringe is. All right, we're maybe taking some medicine or something. We've got 96.6 milliliters. So that's volume, right? 96.6 milliliters. We've got a pressure of 66 or 64. A pressure of 64.4 kilopascals. And the plunger is depressed till the new pressure is 94. So we have a new pressure of 94.6 kilopascals. What is the new volume? So I have a new volume I'm trying to find. All right, assuming constant temperature. So pressure volume, I'm thinking Boyle's law. They're inversely related. So if the pressure goes up, the volume is going to go down. Let's see what happens. I'm going to substitute in. So my pressure was 64.4 times the volume was 96.6 equals the pressure was 94.6 times a new volume that I don't know. All right. And then I want to get rid of this 94.6. Boom. Got to do it on the other side. So my new volume is going to be that, whatever that is. Let's see. 64.4 times 96.6 divided by 94.6. All right, so I get 65. Let's see how many significant digits. Well, I'm trying to find volume. So I had 3 significant digits, so I want 3 significant digits. So 65.7, but then the next digit's a 6, so the 7 is going to go up to an 8. So 65.8. And then what's my unit? This was milliliters, so this would be milliliters. And there we go. All right. Just as a little refresher, if the answer, say you had a multiple choice and it was in liters, if I have 65.8 milliliters, how many liters is that? So remember King Henry, oops, maybe I need more room. King Henry died by drinking chocolate milk. So if I have milliliters and I'm going to liters, right? Your base is liter. Yeah, I'm going over 1, 2, 3. 1, 2, 3. So I got to move this decimal. 1, 2, 3. So I'll put a 0 there. So that would be 0.0658 liters. All right. So you want to be able to go back and forth in case you have a multiple choice test. And also you'll see later on, sometimes you have to go to liters when we start doing our ideal gas laws. So it's good to know. All right, so now we have some neon gas. All right. And it's got a volume of 752 milliliters. So my volume is 752 milliliters at 25 degrees Celsius. So my temperature is
James,
Okay. So we're just gonna get in the habit of converting to Kelvins. So 25 degrees Celsius, all you have to do is add 273 to do that in Kelvins. So that would be 298 Kelvins. Hey, take some pot pies.
$7 a pop.
All right. And it says, what will the temperature be if you have 850 milliliters? So I have a new volume, which is 850 milliliters. All right. It says, what is the temperature? So I don't know the new temperature. So that is my unknown. So volume and temperature, that's Charles's law, right? Volume divided by temperature. They're directly related. If my volume went up, the temperature is going to go up. Okay. So let's see what happens here. And that's how I'm going to check myself to make sure I get it right. So volume, I've got 752 milliliters and 298 kelvins and 850 milliliters, and then I have a new temperature. I don't know what it is. So I'm going to cross multiply, and I get 752 times T equals 298 times 850. Then I'm going to divide by 752 to get rid of that. And so my new temperature is going to be whatever that is. So let's take 298 times 850 divided by 752. So I get 300 and let's see, I had three significant digits here, so I'll just use 3. I'll just say 336, but then the next digit is a 8, so I'm going to make that 337. All right, so my new T is 337 kelvins. All right, let's go ahead and circle that because it's kind of a mess. And did that work out? Yeah, it did. It definitely went up from 298 to 337. So that is probably right. Okay, so, oh, and actually I covered up my thing there. I need to find my, oh, that's why I can't do that. I gotta find my eraser. Gonna have to do it. Gonna have to, yeah, gonna have to erase that. Okay. So here we go. We've got a balloon with a volume of, so your balloon problems are your gas problems usually. Got a volume of 0.75 liters and a temperature of 300 kelvins. All right, and I have a new volume of 0.70 liters, and then I have a new, it says, what is the new temperature? So I don't know the new temperature. All right, so that is Charles' law, right? They're directly related. All right, so my volume went down, so the temperature is going to go down. All right, so let's substitute in here. So the volume, I've got 0.75 divided by 300 equals 0.70 divided by our new temperature. So I'm going to cross multiply, and I get 0.75 T equals 300 times 0.70. And then I want to divide by the 0.75. So that'll go away on both sides, 0.75. And so I'm going to get my temperature. My new temperature is going to be whatever this is. So let's see. I'm going to take 300 times 0.70 divided by 0.75. And I get 280. So my new temperature is 280. What's the units? That was kelvins. All right. So that was amazing. That came out with no decimals. So 280 kelvins. So did that make sense? Yeah, that looks good because the temperature went down. Okay. And now we can just keep on going. We're just going to keep practicing doing this. And notice up here, when I had milliliters, I just left it in milliliters. You could always just move, like we did in class. We actually converted the milliliters. There's your decimal. We moved it over 1, 2, 3 and made that point, right? And we made this into liters. All right, and so, and then we ended up with the same answer, okay? All right, let's look at this one. We've got, let me fix I'm gonna have to erase again.
Call from Leverton, VA.
Oh, there it is. I didn't have to do all that. Darn it. Okay, so now I can see this problem. Alrighty. Okay, so let's do the next one. Number 8, an air mass. So I've got my gas laws. Got volume of 6.5 liters. Volume 6.5 liters. At sea level, all right, where the pressure is 775 millimeters of mercury. So the pressure there is 775 millimeters of mercury. And again, watch the Edpuzzle so you understand the pressure and the units. It rises up a mountain, all right, where the pressure is 622. So I have a new pressure, and that is 622 millimeters of mercury. Assuming no change in temperature, what is the volume? All right, so I'm trying to find the new volume. So that is going to be Boyle's law, right? Pressure times volume equals pressure times volume. They're inversely related, so if my pressure is going down, the volume is going to go up. The air molecules are going to spread out. And that's why it actually gets cooler when you go up in the mountains. So let's see. I'm going to substitute in. So I've got, what's my pressure? 775 times the volume there was 6.5 equals 622 times the new volume that I don't know. All right, and that's being multiplied, so I'm going to divide by the 622. That's 1, so I get 1 times the new volume is the new volume, and then that is whatever that is. So let's come over here, and we'll do 775 times 6.5 divided by 622. And let's see, what do I want to go out to? I had my volume was in 2 significant digits, so this would be 8.0. Look to the next one, and it's a 9, so that means it's going to go up to 8.1. And then the units I had were liters, so I'm going to do liters. All right, so hopefully this is getting easier. we're almost done, I think. Let's see. What do we have here? We have liters of air, so that's volume. All right, and we have a temperature, Kelvin. It's injected into a cylinder. The temperature increases. All right, so I have a new temperature. The pressure is constant. What is the volume? So I have a new volume. What is the new volume? Okay, so temperature and volume, that's Charles's law. So they're directly related. So I'm going to divide them. So I have 1.5 times 10 to the third divided by 278 equals the new volume divided by 280. All right, so now I'm going to cross multiply. So I get 1.5 times 10 to the third times 280, oops, equals 278 times the new volume, right? So I want that new volume all by itself, so I'm going to do divide by 278 on both sides. So my new volume equals, and let's see, 1.5, and now I got to do times. I have to scoot this over. Times 10 to the third. All right, and arrow over times 288. No, what is that? 280. 280. Right, looking at the thing. Yeah, because I'm multiplying these times 280. Okay. Divided by, shoot. Divided by 278. And so my new volume is going to be, and now this was in scientific notation, so if I want to make this into scientific notation, what I've got here is I've got 1,510, right? 0.79, right? So if I write that in scientific notation, right, this is actually, I've got 3 significant digits here. So I want to have 3 significant digits. So this would be 1.51, right? And then I'm going to move this over. 3 times 10 to the third, right? And that would be my new volume. So it went up just like the temperature went up just a tiny bit, and so the volume went up just a tiny bit. All right. Okay, so number 10, we've got 56 liters. Actually, it's hard. Oh, yeah. Oh, yeah. I'm sorry. I thought that's the actual problem number, not. So I've got 56. My volume is 56 liters. I've got a gas, so that I'm going to use my gas laws. And temperature is 350 kelvins. The volume increases, so I have a new volume is 60 liters. And what is the new temperature? I don't know. Okay, so again, this is going to be Charles's law, where they're directly related, so I'm dividing them. And if the volume is going up, the temperature is going to go up. That's what directly related means. So let's see, I've got volume 56 divided by the temperature equals volume divided by the temperature. I'm going to cross multiply, so I get 56 times T equals 350 times 60, right? Then I want to divide by 56 on both sides. And so I get that my T equals, my new temperature is going to be whatever that is. 350 times 60 divided by 56. So 375. My new temperature is going to be 375, and this was in Kelvin, so that would be kelvins. All right, okay, so let's do the next one. Cylinder's got 2.5 liters, so my volume is 2.5 liters. I've got pressure, 600 millimeters of mercury. Oh, and I have a temperature too. So I've got a temperature 22 Celsius, so I'm going to convert that. All right, so I'm going to take, I'll do that down here. 22 plus, oh, no, I'm not going to do it down there. I'm going to do it up here where I have space. 22 plus 273, that is equal to, oh, maybe I don't want to do it because that's going to stay there. Oh no, I can't get rid of it. All right. Where am I going to do? I'll just do it right here, I guess. That makes more sense. 22 plus, the magic number is 273. So that would be 295 kelvins. All right. The volume is decreased, so I have a new volume to 1.8 liters, right? Volume 1.8 liters. Pressure is going to increase to 760 millimeters of mercury, and it says, what is the new temperature? So we're using the combined gas law, right? So that was where you have everything together, pressure, Boyle's law, and Charles' law at the same time. And then you just substitute in. So I've got pressure, so 600 times 2.5 all over the temperature was 295 equals pressure 760 times the volume was 1.8 all over this T that we don't know. Okay, so and then what we're going to do is we're going to make this into a number. You know what? I don't know if I can go back. Let me erase that. okay, what we're going to do is we want it to be just a proportion, all right, like we did up here where we can cross multiply. So how about I'll do this? I'll get 600 times, times 2.5, and that gives me 1500 over 295 equals, and then what's 760 times 760 times 1.8 is 1368. Let me scoot this over. Okay, so that gives me 1368 over t. Okay, now I can cross multiply. And I'll get 1560, right, multiplying these two together times t equals, and then I'll multiply those two together, and I'll get a number there. And just because I'm running out of room, I'm going to actually do it over here first. 295 times 1368. So that gives me 403,560. All right, and then now I'm going to divide by the 1560, right? So that goes away. Divide by 1560. What a mess. Actually, I'll just divide by, oh, I'll write it down. 403,560 divided by 1560. All right, and then my new temperature is, and then my old temperature just had 3 significant digits, so that'd be 258, and then 0.6 though, that means I'm going to round that up to 259. So 259 kelvins. All right, so I needed a little more space there. Oh well. Here we go. We've got our argon gas in a balloon. So we've got the gas laws, balloon, a new volume, 2.5 liters, Celsius, so a new temperature. So I'm going to take my 35 and I'm going to add the magic number, 273. And so that gives me 308 kelvins. All right. The balloon is dipped in ice. Again, that seems to be what we do. We put that in ice and we change the temperature to negative 15 C. So I'm going to take the negative 15 and add 273. All right, so that's basically like subtracting, right? If I take 2, well, let's see. I don't know if I can do, if I just do negative 15, I guess that will work, plus 273. That gives me 258. Okay, kelvins. And then it says, what would the new volume? What is the new volume going to be? So what is the new volume? All right, so I've got volume and temperature. They're directly related, right? Charles's law. And so my temperature went down because I put it in ice. And so my volume is going to go down, right? It's going to get smaller. So let's see, I've got volume 2.5 over 308 equals my new volume, I don't know, over 258. and 58. Okay, then I'll just cross multiply. So I get 2.5 times 258 equals 308 times V. Divide by 308. So my new volume is going to be 2.5 times 258 divided by 308. So let's see, I've got my volume was 2 significant digits, so that would be 2.0, but then you look to the right and that's a 9, so I'm going to make that 2.1. And what's my unit? Liters, so I'm going to make that liters, and that is my new volume. All right. There's so many. Oh, there's only 2 more. We're almost done. All right, here we go. So we've got 2.75 liters. All right, I've got a new temperature. So I'm going to take that 40 and add 273. All right, so let's take 40 plus 273, and I get 313 kelvins. And now I've got a new volume, 246, so my new volume is going to be 2.46 liters. And the question is, what is the temperature? So what is the new temperature? So volume and temperature, right? Directly related, Charles's law. So volume 2.75 divided by temperature equals volume 2.46 divided by temperature. So the volume went down from 2.7 to 2.4. Volume goes down, so temperature goes down. They're directly related. So I'm going to cross multiply 2.75 times the temperature equals 313 times 2.46. I want to get rid of the 2.75. Boom. Divide by 2.75. So my new temperature, I guess I'll just write it here. My new temperature is going to be what that is. So 313 times 2.46 divided by 2.75. All right, so we had 3 significant digits, so that would be 279. I'm going to look to the right, so it's a 9, so I'm going to round up to 280. So my new temperature is 280 kelvins. It went down to 280 kelvins. The last one, finally. Okay, so let's see. How about we'll go back to green. So I have, I think, is that a comma? I think it is. The volume is 1,500 liters of air. Oh yeah, into a household furnace. Okay, so that's my initial volume. It's 5 degrees Celsius, so I'm going to take the 5. I got a new temperature. Take the 5 and I'm going to add 273. So that would be 278 kelvins. All right, and then I've got a new temperature, which is 30. So I'm going to take 30 and add 273, and that gives me 303 kelvins. And the question is, what is the volume? So what is my new volume? So that is Charles's law, right? Volume divided by temperature equals volume divided by temperature. They're directly related. So if my temperature went up, the volume is going to go up. So let's substitute in. So 278 divided by, oh, that's my temperature. I could flip both of them if I wanted to, but I'm going to stick with this. I'm just going to substitute in volume, so 1500 over 278 equals the new volume over 303. And then I'm going to cross multiply, so I get 1500 times 303 equals 278 times the new volume. So I'm going to divide by 278, so that goes away. Divide by 278. So then over here, I've got 1500 times 303 divided by 278. All right, so basically I had, like, this was thousands, so or we'll say I'll go ahead and leave it as thousands. It actually is only 2 significant digits. Remember, if there's no decimal, you start at the Atlantic and skip the 0, so there's only 2 significant digits. So I could do this to 2 significant digits. That would be the 1 and the 6, and then I'd round. So that would be 1600. But let's go ahead and we'll just write it like out to the thousands. So 1634, but then the next digit is a 8, so I'll make that 1000. So my new volume here, I'll just write it in over here, is 1630. Instead of 4, I'm going to put 5. All right, and on your test you will have multiple choice. So as long as you get close, you just pick the one that's closer, the closest. All right, very good, and thank goodness that is it. 14 problems. Good job. And then we'll start practicing with the ideal gas law and partial pressures, and we're done with gas laws. So good work.